All right, what's up, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we're going to explore a little bit an introduction to graphing the tangent function before we actually formalize it. So let's kind of go over a couple of things about the tangent function just to review ever so slightly. Now remember, the tangent function is going to be the sine divided by the cosine. So it's going to be the two trig functions that we'll take a look at. And we also know from the unit circle, tangent and sine and cosine, they're all related by x, y, and r, and sine is the y coordinate and cosine is the x coordinate. We don't bother with the divide by r because they would both cancel out. So more on that in a little bit. We're not here to discuss that, but let's take a look at the picture of the tangent function. So notice what's going on here. We've got this function that kind of looks like the cubic function, a little different, but again, it's periodic. So it's going to be going on and on and on forever and ever and ever. And we can zoom in and out. It's like, oh, there's multiple versions of it because that's what makes a function periodic. Now, as we know, as we look at this function, it's like, well, it appears that it goes up and down forever, but left and right, if we look left to right, it looks like there are these asymptotes. Like the function, there's these barriers that are going on. So if we think about that, it's like, okay, sine divided by cosine. And from that perspective of sine divided by cosine, we're just looking at a rational function. Anytime that the denominator is zero, like that's bad. We don't like that. And so what happens graphically when we have the denominator of zero, so where cosine is zero would be right here at pi over 2, and then another time at negative pi over 2. And if we zoom out a little bit, and we can see all these different multiples where the cosine function on the unit circle where it's zero. It's all these different values, right? But notice what's happening there. At all those values, the tangent function, notice what happens, boom. Anywhere cosine is zero, we've got these asymptotes going on. So check that out, man, that's pretty cool. Let me get rid of cosine here so we don't have as much squibbly squabbly going on our picture. But look at that. So everywhere that the cosine curve was zero is where we're going to have these asymptotes. So, and notice how far apart these asymptotes are. So on the left side, you know, we see negative pi over 2, and then we see pi over 2. And then we see a 3 pi over 2. And if we keep going to the right, and then we'll see 5 pi over 2. So these are all odd multiples of pi over 2. So I'm curious though, as we look at each one of these functions that's kind of contained, so it's almost like there's these walls around the function, around the tangent function, and it's like every odd multiple of pi over 2, thou shalt not pass. It's like Gandalf is standing there with his nice little wizard and his staff saying, nope, you can't go past odd multiples of pi over 2. So why is that? Well, that's because, again, that's where the cosine function has a value of 0. So anywhere those cosines are 0, that's where we're going to have the vertical asymptotes for the tangent function. Pretty cool, right? So now we'll formalize this, and we'll come back to that in a little bit. But also, let's talk about the period. So remember, the period is how long does it take to complete one full cycle of the graph. So if we look at any of the vertical asymptotes, we can pick any two we want and find the distance between them. And just because we're gonna work with some positive values here, I'm gonna use 3 pi over 2 and pi over 2. So let's kind of formalize that here for a second, shall we? So if I look at the distance between pi over 2, so since we're doing distance, we're gonna do the absolute value. So pi over 2 and 3 pi over 2, so that distance between those two. Now remember, there's basic arithmetic here, so pi over 2 minus 3 pi over 2, we'd get negative pi over 2, but when you find the absolute value of that, you get pi. So the distance between the asymptotes is pi, they're pi apart, which is going to play into the period a little bit, right? So the period, how long the function takes to repeat, the period is going to be pi, unlike sine and cosine, where the period is 2 pi. And again, we can kind of see that if we turn the cosine function on to complete one full cycle. So let me turn tangent off and the asymptotes here. If we take a look at the cosine function, to get from 0 to 1, go all the way down. So this is basically the first quadrant. If you think about the unit circle, first quadrant, we've got some positive values of x. and y. And then we go down here, we get all the negative values, we see our graph dipping down, 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 and then we come all the way back up. So the distance between our maximums, 0 to 2 pi, is a distance of 2 pi. So that's why the cosine function has a period of 2 pi. Same thing with the sine function. That one's a little bit different, right? Because the sine function will start on, not that one. That one starts on the axis, but the next time we cover all the positive y values and all the negative y values, that whole cycle is 2 pi. But tangent, no, we can get all the positive ones and the negative ones in between those values. Oops, not that spot. In between the asymptotes, which is negative pi, or pi over 2 to 3 pi over 2, which is just a value of pi. So the period is pi. So that's what makes this one a little bit different. So that's a quick introduction to graphically what's going on. Then we'll come back and formalize these with our notes a little bit more. But we already know at pi over 2, we're going to have an asymptote. So we're going to have, that's going to be undefined, and a negative pi over 2. Those are going to both be undefined at those values. So we'll take a look at the zeros and all the other things a little bit more in the next video. So come on back and take a look at that, and I'll see you guys soon. Peace out.